Hey guys, welcome to this page of the notes, and again what we're doing is sequences of transformations. Now I'm going to give you the transformations in a slightly different way. You should still recognize it though, we have seen these before. Let's just go ahead and jump right into these to see how they're going. Hopefully you tried them on your own and you're just coming back now to check and see how you did. Alright, here we go. I've been given a quadrilateral, and what we're going to do is perform the following sequence of transformations. One quick note here, and I apologize if you tried this on your own. Small typo right here. That should not be 3 over 3. That should be 3 over 2, right? So 3 halves and 3 halves. All right, here we go. Let's just jump right into this. First, my vertices, A, B, C, and D. All right, awesome. Here we go. A. A is at, let's see, that's positive 2, 2, 4. Okay. B. B is at 1, 2, 3, 4, 5, 6, 6, 4. C is at 2, 2, and D is at 4, 2. 4, 2. All right, now what we're going to do is perform our first transformation, and it's given to me by this guy right here. What this is telling me to do is multiply the x-coordinate by 3 halves and multiply the y-coordinate by 3 halves, right, to get my new image. Well, let me show you how this is going to work for A, and then we'll take a look at the rest of them because we're going to practice a little bit of mental math here. I think you guys will get really good at it. So what they're asking you to do, the transformation A prime is going to be given by this. We're going to take 3 halves and multiply it by the x-coordinate, right? Multiply it by x. Well, for A, that's a 2. Then, the y-coordinate, right? The 4, multiply it by 3 halves. Multiply that by 4. There we go. So, A prime is given by, well, how do you do this? I have 3 halves multiplied by 2. Guys, really, really simple. All you have to do, multiply the constant into the numerator, right? And then divide by the denominator. So, 2 times 3 is 6. 6 divided by 2 is 3. And 4 times 3 is 12. 12 divided by 2 is 6. So what we see here then, actually I should do this in a different color. A prime would be at 3, 6, right? That's applying this transformation. Okay, let's go ahead and do the rest of these in our head because I think we can. Let's practice mental math. Good mental math. Here we go. You're going to multiply 6 by 3 halves. So 6 times 3 is 18. 18 divided by 2, 9. So B prime is going to be at 9. Keep going. 4 multiplied by 3 halves. Well, we've already seen this one. 4 times 3 is 12. 12 divided by 2 is 6. That's good mental math, guys. That's good mental math. Hopefully you can see that in your head, right? Got a really good calculator right here. Let's make sure we exercise that calculator. So 2 times 3 halves. 3 times 2 is 6. 6 divided by 2 is 3. Exact same thing. 2 times 3 is 6. 6 divided by 2 is 3. And let's get D prime. All right, 4 times 3 halves. We've seen this one a couple of times. 4 times 3 is 12. 12 divided by 2 is 6. So that's going to be at 6. And then we've seen this one a couple of times. 2 times 3 is 6. 6 divided by 2 is 3. Hey guys, that is really, really good mental math. Well done. You should be able to multiply a constant by fractions all day long without the use of a calculator. It's good mental math. All right, let's plot these points. 1, 2, 3, 4, 5, 6. Right there, that's A prime. B prime, 9, 6. Woo, 9, 6. That's right there. That'll be B prime. 3, 3. 3, 3. Put C prime right there. D prime. 6, 3. 3, 4, 5, 6. Right there. D prime. Now, here's what you should notice. Hopefully you can pretty clearly see that my image has gotten bigger, right? I've stretched the original figure to what is now my new figure that's bigger. I've increased its size, right? I've stretched that figure. I have not preserved shape or size. That's because this guy right here is what's known as a dilation. And recall, a dilation is a non-rigid transformation. It does not preserve shape or size. Awesome job, guys. Here we go. Let's keep going. I'm now going to take my prime coordinates, my green triangle, and perform this transformation. Let's see how it goes. So, A prime, which is at 3, 6, and B prime, which is at 9, 6, and C prime, which is at 3, 3, and D prime, which is at 6, 3. Perform the transformation. Let's do it in yellow. I'm going to leave the coordinates as is. Please look, it's still x, y. The only difference, they want me to make the x coordinate negative. Easy, 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 easy. So A double prime is going to be a minus 3, 6. B double prime is going to be a negative 9, 6. C double prime is going to be a minus 3, 3. And D double prime is going to be a negative 6, 3, right? In order to apply this transformation, you just make the x coordinate negative. That's all you're doing. And plot those points. Okay, here we go. 1, let's see, 1, 2, 3. Right there. A double prime. B negative 9, 6 puts me right there for B double prime. 3, C double prime. And D double prime. Boom, 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 boom. Hey, what does that look like? Do you recognize it? You went from this guy over here to this. Do you see? Do you see, right? It's just a reflection across the y-axis. All you've done, that guy right there, is simply a reflection. Please notice that the image we reflected, right, it maintained shape and size. That's because a reflection is a rigid transformation. We've just simply reflected it across the y-axis, but we're not done yet. Now we've got this one. Okay, awesome. Here we go. So I start with my double prime. We'll go to black this time. So we're going to have A double prime, which is at negative 3, 6. B double prime, which is at negative 9, 6. C double prime, which is at negative 3, 3. And D double prime, which was at negative 6, 3. Here we go. Let's perform these transformations. A triple prime. What do they want me to do? They want me to add 1 to the x, subtract 2 from the y. We can do that. Negative 3 plus 1, that's a minus 2. Then, negative 6 minus 2, well, that's 4. Okay, keep going. B, triple prime. Well, it was at negative 9, they want me to add 1. That's minus 8. Then, 6, they want me to subtract 2. That's 4 again. C, triple prime. They want me to, right, -3, they want me to add 1. -2. 3, they want me to subtract 2. That puts me at 1. And D, triple prime. -6, add 1, -5. 3, subtract 2, 1 again. Plot those points. Here we go. -2, 1, 2, and 4. 1, 2, 3, 4. Right there is A, triple prime. -8, -8, 4. 1, 2, 3. Right there is B, triple prime. 2, 1, right there. That's going to be C, triple prime. -5 right there. D, triple prime. Perfect. Fantastic. There we go. That is my last transformation. It's this guy right here. Do you recognize it? Do you see what it is? Do you see it? It's a translation. Please notice, from the yellow quadrilateral to the black quadrilateral, it has not changed shape or size. Same shape, same size. It's simply been shifted to the right one and down 2. Right 1, down 2, right? Over 1, down 2. Over 1, down 2. Over 1, down 2. Over 1, down 2. Remember, a translation is a rigid motion. It preserves shape and size. And so what we've got right here is a sequence of transformations. The first transformation changed the shape and the size. It was a dilation. After that, the reflection preserved shape and size. The translation also preserved shape and size. But my final image is different than my original, right? These are not the same shape and size. It's because of that dilation. That was a non-rigid transformation. Really, really good work, guys. I've got one more for you right here. Again, it's good practice. Lots of example problems just to make sure you get good at this before I send you off to try some on your own in a homework or a quiz or whatever it may be. Here we go. A, B, C. Let's do this. A prime. No, not A prime. I apologize. Just A. It is at the point 0, -2. 0, -2. B is at -2, -4, -2, -4. Okay. And C is at 4, -4. So -4, -4. Hey, let's do our transformation. I'll do this one in green. My first transformation is multiply the x by 3, leave the y alone. Okay, we can do that. So, A prime. What is 0 times 3? 0. Y coordinate, don't change it. Just stays a -2. B prime. Multiply the x by multiply the x by 3, so -2 times 3, well, that's a -6. The y coordinate doesn't change, just stays a -4. Then the next one. Okay, here we go. -4 times 3, that's a big one. That's going to be -12. We'll try and, it won't quite fit on here, but we'll squeeze, it'll be fine. And then the y coordinate doesn't change, stays -4. All right, here we go, let's plot those. 0, -2, so look at that. Actually, A prime, right? It doesn't change. It stays the same. Okay, cool. B, -6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3. Right there. That's going to be B prime. I'm going to have to add a couple of little hash marks here. Sorry about that. It goes to 10. Let's say that's 11. There's 12. That looks pretty good to me. Okay, here we go. So we're going to be at negative 12 minus 4. 1, 2, 3, 4. That puts C right out about there. C prime. All right, here we go. So there's that, then that, and yeah, that's all right. That's not bad. For freehanding it, I'll take it. I'll take it. Anyway, there's my triangle. What do you notice? What do you see? What happened? Yeah, we changed the shape and the size. This guy right here is what we call a dilation. We changed the shape and the size. It is a non-rigid transformation. These two images are no longer the same shape or size. Yes, they're both triangles, I get it, but they're triangles of different shapes, right? And they're definitely not the same size. So dilation does not preserve shape or size. Here we go. Next one. We go from A prime, which is at 0, negative 2, B prime, which is at negative 6, negative 4, and C prime, which is at negative 12, negative 4, and I feel like I made a mistake. I did. I apologize once again. I am so sorry. I do have a typo here. Actually, scratch that guy out. Here's the transformation. I want you guys to do 1/2 x, comma, minus 1/2 y. Okay, so instead of that, don't do that, do this one, all right? So here we go. I don't know, let's do it in yellow. A double prime. Well, here we go. I'm going to multiply 0 by 1/2. Well, 0 times anything is 0. Okay, great. I'm going to multiply a negative 2 by 1/2. Again, the negative 2 gets multiplied into the top, so that is a negative 2 divided by 2, which is minus 1. Right. Minus 1. Okay, keep going. B, double prime. Here we go. Negative 6 times 1/2. Negative 6 goes into the top. Negative 6 divided by 2, minus 3. Keep going. Negative 4. Negative 4. I'm so sorry. I am so sorry. Scratch that again. I keep doing really weird stuff. Hang on. Did you see what I accidentally did? I took the negative 2 and multiplied it by a positive 1/2. Nope. This is my y value, right? So negative 2 gets multiplied by a negative 1/2, right? So negative 2 times the negative 1, positive 2 divided by 2, this should be a positive 1. Now, I will not make the same mistake again. Negative 4 times the negative 1/2, negatives cancel, 4 divided by 2, positive 2. Fantastic. C prime. Try really hard not to make mistakes. Here we go. Negative 12 divided by 2, minus 6. And negative 4, put it in the right spot. Negative 4, the negatives cancel. 4 divided by 2 is 2. Plot those points. Here we go. We're going to go 0, 1. So right there, that's going to be A double prime. Then we're going to be at negative 3. 1, 2, 3, positive 2. Right there, that's going to be B double prime. And then C. 1, 2, 3, 4, 5, 6, 2. It's going to be C double prime, and once again, whew. Now, what we've done, hopefully you recognize it, right? By making the y coordinate negative, you've done a reflection, right? You've taken this guy right here, this one in green, and reflected it, right? We've reflected it across a line of reflection, right? We've gone across the line of reflection, but more than that, you've also done yet another dilation. So right here we have two things happening. This is both a dilation slash reflection. And the point here, before we finish, these last two example problems we've done, neither shape or size has been preserved because we've done non-rigid transformations. We've changed the shape or the size of our original figure. When we did the transformations, our final transformation's a different size and a different shape. Okay? So hopefully that makes sense, guys. Thank you so much for joining me for this set of videos. Hopefully at this point you feel even more comfortable with all of the transformations and performing more than one transformation, doing them in a sequence. Again, thanks for joining me. I'll see you guys next time.